Oh, okay, we are back now. Here is problem 3, I believe. Let's see, 3. That's where we have the ship being pushed by tugboats. So there's our ship. It's being pulled by one tugboat with a force of 50,000 newtons. You know what? Instead of writing 1,000, I'm just going to do kilonewtons. And another ship is pushing down, or sort of that way, at a 45-degree angle. There's your other ship. 45 kilonewtons, and then at 35 degrees we have a ship smashing it. Oh, I hope that guy goes to the main office right away. Okay, so anyway, 40 kilonewtons, 45 kilonewtons, 50 kilonewtons. So let's draw the free body diagram. Oh, and then we've also got friction force in the from the boats on the boat. So like F sub F, something like that. I don't know. So let's do our free body diagram. FBD for the ship. Doink, doink. Okay, so here's our X, Y, Y, X. Okay, so here's the ship, and with one force going horizontal. Oops, let's do a little better there. There we go. Horizontally, 50 kilonewtons. Newtons. There we go. One force is 45 kilonewtons. Newtons. 40. Boy, I can't do anything right now. All right, 45 degrees, and then another one coming up at about there, 35 degrees, and that is 40 kilonewtons. And then lastly, we have friction, which is coming back here at some angle we don't know. So I'm going to sort of assume it's a positive angle, or it's up like that, and then we'll find out later whether it's, up or down. So we have that theta, and this is force of friction. Okay, well, actually we won't find out because we're not going to solve this problem, but had we solved this problem we would find out. So, second free body diagram, where we resolve everything in components. Here's your dot again. I'm going to redraw our coordinate axes. This is not strictly necessary, but I'm going to do it because I like to. Okay, so we have, for starters, oh god, come on, there we go. Okay, so there's our 50 kilonewton force. This force here is going to be 40 kilonewtons times cosine of 35 degrees. This one up here is going to be 40 kilonewtons times sine of 35 degrees. Okay, so that was just breaking this one down vertical, horizontal. Breaking this one down vertical, horizontal. 45 kilonewtons times sine 45 degrees, and bigging that thing up. And I've said this before, but if you need a bigger dot, you just make a bigger dot. Just flesh that dot right out. Make that dot big. Cosine 45 degrees, and then finally, and this is where I kind of don't like this thing where you have the friction force and we don't know exactly which direction it's pulling. Although you sort of surmise it's going to pull straight back on the ship. But I'm going to say this is friction force times cosine theta, and then maybe we have a little tiny bit here, which is friction force times sine theta, and then maybe this is positive or negative. Who knows? I don't know. But anyway, that's how I would solve that problem. Let's move on. We're under 4 minutes so far, so let's move on to problem 4, where we've got a ooh, this is a fun one. Block against a wall. Block against a wall. All right. So there's our wall. Oink. There's our block, and there's our horizontal line, and right there this force is acting like that, and the angle theta there. Let's see, push a, all right, he pushes, so this is a student with a broom handle pushing with a force against this block. There is friction there, and it's going up a wall, so velocity is going that way, greater than 0, I'm going to say. Okay, so let's do our FBD for the block. Boom, boom. And let's start with, first of all, draw axes, as always. Okay, so X, Y. Okay, and we have a dot for the block. So let's see, what are the forces acting on the block? Let's start with weight. It's going to go straight down, we know that. We're going to have a normal force from the wall, which is going to be pushing here. I'm going to draw the forces in like that. So there's the weight, there's the normal force. We have this force acting like that, and then we have the friction force, which is going against the direction of motion, right? So that's our four forces that we have there: normal, friction, weight, and then applied force. Okay, so mg, and then we have our friction force also go down. So I'm going to do that. We have our normal force headed that way, and then coming up here at an angle theta from the horizontal, we have our applied force from the broom handle. Alrighty, so let's do this, and there's normal force, mg, friction force. So this is our, by components thing, and we're going to break this all up. And then so we just have to break a force up, the applied force from the broom handle up into horizontal and vertical. And that's pretty easy because this is angle theta from the horizontal. So we have F cosine theta, and this is going to be F sine theta. Wow, and I'm still 6 minutes. So, and number 5 looks kind of complicated. So I'm going to cut this here and come back in a moment and do problems 5 and 6.